welcome to Dr. Gary Parker.
Okay, well, it's always a special treat for me to be here with you, and congratulations. And so I understand that Brian, in addition to working with the Rocky Mountain Creation Fellowship here, is also signed on to be a speaker with Answers to Genesis. Is that right?
Yes.
And so I know they'll keep him plenty busy, so you guys will be sending another missionary out into the field. And on behalf of the Creation Adventures Museum down in Florida, we're happy to be one of the early ones, right, to sign on to the Creation Weekend program, and we intend to follow through with that. And so I think Bill Browning, you kind of spearheaded that idea, and that started here to kind of spread around the country. That I encourage churches and educational units around the country to plan at least one Creation Weekend celebration a year. Partly, I'm not opposed to having a second one in February when, an enterprising person about a couple years ago wanted to do an Evolution Sunday in the churches. The Sunday nearest Darwin's birthday. Well, Darwin's birthday happens to be Abraham Lincoln's birthday. And so that had quite a different spiritual outcome than Darwin's journey did. And so we might have a mid-year break for a Sunday and then another Creation Weekend. So I encourage you to continue the tremendous outreach that you have. And you can get behind the leadership. I think the Denver area really needs one of the ICR RATE conferences, Radioisotopes and the Age of the Earth. So it's been my privilege to be the general speaker for the scientists that present this fantastic evidence directly from radioactivity studies and so on in favor of young Earth. Well, this evening, it's my pleasure to talk to you about plant power. It's one title that we gave to this. Pardon me just a minute. I'm almost exhausted from talking with my son-in-law already. Another way to title this would be Capitalizing on Chaos. And so that's the one I kind of use in classes. And of course, you people are the ones that actually like, these kinds of talks that I don't get to give to anybody else. And I actually went out of my way this afternoon and handcrafted, okay, for your enjoyment, entertainment, and information. Okay, a fantastic, one-of-a-kind diffusion box. Okay, and so there is, whoa, already warming up. Okay, I was going to tell you, there it is at absolute zero. Okay. And so if you think of these little black spheres that you see there as water molecules, this would be water molecules or any other, particle, even subatomic particles. Well, at least atomic particles at absolute zero, by definition, is a time when there's no motion of atomic particles from one place to another. I guess even at absolute zero, there's some internal vibratory motions, but no translational motion, no going from one place to another. Well, what happens if you add a little heat? Okay, you begin to warm things up, and wouldn't that be a nice idea? Okay. And so, of course, I'm fresh from Florida. Yeah, I told Bill I brought a young man with me from Florida to help me do some work in the California house. And one of his prayers was to see snow while he was here. See, it's his fault. So he's got that answered in spades. But at any rate, we'll add a little heat. And adding a little heat produces a little molecular atomic motion, from place to place. And now we need to add more heat. And you say, well, what's heat? Well, heat is molecular motion. Well, what causes molecular motion? Well, the answer is heat. And you may notice a fundamental circularity there. It's really kind of impossible to define heat and molecular motion separately from one another. But that's kind of a general tendency. A lot of things, you just have to accept. And it looks like one of the fundamental features of our universe is that small particles are in a constant state of random, chaotic, bump into each other motion. And that motion can be slight, if you're just a little bit above absolute zero, to being so violent that it strips the particles away from the atomic nucleus. And at life temperatures, the so-called biokinetic zone, a very small range between absolute zero and the temperature of stars and things like that, you have this nice, pleasant place we call home, where you have solids where the particles kind of vibrate in place, and liquids, which is kind of what I'm illustrating here. Particles will flow around among one another, bump into each other, but don't really jump up out of the container. And then gases, where they would jump up out of the container and spread out, much more widely. And so this is kind of the area of our common experience. And so you can think of these as water molecules, at room temperature. Okay. Well, you may notice, this dividing line here, handcrafted this very afternoon. Okay, from a fantastic piece of cardboard. Okay. There's some pores in it that you probably can't see here, but I've got a semi-permeable membrane. That is a membrane with some holes in it that lets some things through and not others. Well, in this particular case, water molecules can move easily through this membrane. And if I start off with a situation where all the molecules are on one side, we could think of this as a membrane of a living cell or about anything else like that, and I just add some random molecular motion. You can see what happens, and so right now it's a little lopsided on this side with 1, 2, 3, 4, 5 on this side, so there's 12 total, 7 on this side. And now let's see, 1, 2, 3, 4, 5. One tie, okay, one stuck in the middle there. But you can kind of get the idea that on average there's going to be 6 particles in this side, 6 particles in that side. It's interesting, this phenomenon here, just the tendency of molecules to scatter out due to random thermal motion, is called diffusion. And in one sense, you'd say, well, diffusion's random, chaotic. It moves things apart, scatters them out. But if you've got a relatively confined space here, notice that even a random process, that is the individual particles are behaving in a random way, actually produces some very predictable results. And so if you have water molecules freely able to go through